I stupidly forgot to review that. So I won't be recording today, but if I go through and check it's a-okay for the next time, I absolutely will.
Sounds good.
Yeah, okay. I see like some people are filtering in. We're like 3 minutes in. Yeah. So I've got a copy of the review practice exam that we can just start from the top, work our way through. Or I can field questions. Totally whatever you guys want to do for the next couple hours. And I've also got the chat here, which I'll do my best to keep an eye on if anybody's too afraid to speak up and wants to drop a question there.
Yeah, I'm good to start with the review. We can dive right in if you want to get your iPad going.
Yeah, everybody else good with that? Do the thumbs up emoji if that's cool or no objection. Okay, excellent. Yeah, let's see if I can figure out oh, wait, we got something in the chat already. What do we got here? Most professors allow open note exams. Why did you choose for our exams to not be open note? Just curious. That was actually not my decision. Um, I do not know why there is no cheat sheet. That is the decision of the course chair. I just managed this section, so that was ultimately not my decision. So I do not know why there are no cheat sheets allowed. So I don't have a good answer for that. Sorry, Emily. Cool. If there are no objections, then yeah, let's toggle over to the review. Let me see if I can share my screen from my iPad, as long as Zoom doesn't get upset with me.
Hey Matt, can you hear me?
Yeah, what's up?
Got a question on the well, first off, appreciate you doing this. But for this exam review, you said there's 13 questions on the exam. Can
That
you
is correct.
the obviously not those exact 13 questions, but the ones that would most likely be similar to those 13 questions?
So
That
I cannot divulge exactly what's going to be on the exam, but I can say that those 13 questions, whichever ones they are sprinkled throughout the 30 that's on the practice exam.
okay.
Yeah, I'm sorry. I really cannot give out any more information than that.
Okay. If you're worried about, since you just said it's just your first year at ASU doing, that's how other professors have done it. If you're worried about it being a thing, like you're 100% correct. It's you can't do open note or anything, but they have done their exam review is basically saying what the 13 questions are going to be without actually giving the exact 13 questions. Just if
Right. Okay. Well, I'm still going to stick to the review
oh,
material.
100%,
Um,
100%.
like I said, the 13, whichever ones they are, they're sprinkled in there.
Appreciate that. Appreciate
Yeah,
that.
yeah, I really don't feel comfortable giving. I mean, I'm glad that you guys are all here, but I mean, of course you are getting an advantage because you are coming through the review session, but I can't give information just to you guys about the exam that I'm not giving to everybody else.
Of course. Of
Yep.
course. But I appreciate knowing that. So I'll hit this exam review pretty hard.
All right,
So
cool.
thank you.
Should we just dive in, go through that guy?
Yeah.
All right, let's do it. I stopped the share. Now let's do it again. All right, let's see if this will work. I think I got this in my good notes. Come on. There we go. Good notes. There we go. Yep, so I've got a copy. This is just the review, of course. I just downloaded it, but I've also got a sheet here of just some blank paper that if you guys have any specific questions, I can also work on them there. But yeah, let's dive into it. Oops. Yeah, so I will apologize. The download got a little funky. I'll do my best to rewrite anything if it's unclear, like some just jumbled line of code. Actually, let me pull up the exam review here. Give me just a second. Because infinity is just like a maze and nothing is ever where it's supposed to be. I'm sure you guys all hate Infinity. And if it makes you feel better, I do as well.
Nice.
All right, so let's just dive in here. Number one, if you have any questions, just shout them out. I'm going to do my best to keep an eye on the chat, but yeah. So let's take a look at number one here. We got lemon cars, and this chart is kind of annoying, so maybe I'll just rewrite that. What do we got? 1, 2, 3, 4, 5, 6. Uh, 24, 15, 9, 24, 27. Right on. So an average rate of change question given a chart of data values. Let's see, what is that? 4 in the chat. I don't know what 4 means here, but okay. So let's say we want to find the average rate of change over a particular interval between weeks 1, 2, and 5. So for a question like this, all I really need to remember is what is the average rate of change formula over an interval. So if I just recall, average rate of change, let's say in this case of, maybe I'll say f of x, let's say over the interval, say AB, that's just going to be given by the slope formula for a line. And that's just because the average rate of change is the slope of a line, namely the slope of the secant line. So in this case, if I want to find the average rate of change of this function, s of t, between 2 and 5, I might say s of 5 minus s of 2 all over 5 minus 2. And luckily for us, we can read those data values right off our little chart. Again, I had to rewrite it. Looks like s of 5 is this guy, and s of 2 is here. So maybe I'll just jot that down as 27 minus 15 all over 5 minus 2, which is 3. And I know I've got a little bit of space. If I ever run out of space, I'll just go over to my scratch sheet on the other side. But we can crunch that out. 27 minus 15 sounds like 12. 12 over 3 sounds like 4. And now I see where that 4 in the chat was coming from. Somebody was faster than me.
Yeah, that was fast.
Gotcha. Yep, I'm gonna go through, explain the process, but yeah, if you got the answer and you want to try and beat me, go for it. And of course, now I've got this numerical value, and so maybe I would drop that in here. But I might also ask, what are the units associated? And I might be asked to interpret this result. So certainly I can say that this is increasing because I got a positive number here. But if I ever care about what the unit is, usually the answer is already nestled in there somewhere. Because if I talk about a rate of change, it's going to be something per something. Well, S of t is going to be the number of cars. Excuse me. And my denominator there is going to be the difference in the weeks. So if I put that, what is that going to be? Cars per weeks. Looks like C here. In general, these answers will be something per something. Think about like miles per hour. Any questions? Number one here.
No questions.
Something in the chat, A and C. Allison, you're lightning fast. All right, let's move on to number two here. And of course, like the question got split across 2 different pages, but it looks like we got a graph here. Time keeping track of the number of soccer games versus the number that are won. Or excuse me, games won per year. And if I just check, I want to ask what the rate of change is here in games won per year between 2012 and 2020. Is it okay with everybody if I just jot that down on the other screen? Awesome.
Yeah, no problem.
I just don't want to keep going back and forth. So let's say we're asking for rate of change. Let me just double check that was. Yeah, okay, yeah. Between 2012 and 2020. And again, if I ever see the rate of change over an interval, it's always denoting the average rate of change. And so I want to do the same thing as before, but now using these graphical data points. And so if I say I'm interested in between 2020 and 2012, all I need to do is look at those corresponding points on the graph. And again, if I give this a graph a name, maybe I'll call this, maybe I'll say G of T, games versus time. I'm really looking at G of 2020, writing, minus G of 2012, divided by that difference in time. And certainly I know what that denominator is. I can do that subtraction. But if I want to find the y coordinate, or excuse me, the outputs, that's really going to be the y coordinate of these points on the graph. And if I just jot down, maybe zoom in a smidge because my eyesight is not that good. It looks like at 2020, we only won 34 games. And in 2012, it looks like we won 58. And if we crunch the numbers there, and unfortunately, I do not have a calculator with me, but I'm going to do my best. Minus 24 over 8. Looks like a loss of 3 games per year. And so I see Allison in the chat that, yes, absolutely right, we're decreasing. So in general, going from year to year, we're losing 3 games less. Or excuse me, winning 3 games less or losing 3 games more. Does that make sense? And another way to interpret this result, if you want to, stick with this picture, this is really the slope of the line here, connecting these 2 dots. And that's sort of your graphical interpretation of rates of change. If anytime you see a rate of change, there's a slope of a line somewhere in there. All right, I'll pause real quick and look at the chat. Any questions, number 2 here?
No, sir.
Right on, just steaming right through. Oh, and I guess we could say -3 there. All right, number 3 here, another average rate of change. And I'll let you guys maybe decide, because it seems like there's multiple types of problem in the review. So you can actually kind of get a theme. Again, I can't really divulge exactly what's going to be on the exam, but you can kind of see that we've got 3 rate of change problems in a row. And 30 divided by 3 is 10. So there's a very good chance that there's one average rate of change problem on the exam. So maybe that's the most I'll say about that. But should we do number 3 here, or do you want to skip it, move on to something else that's not rate of change, average rate of change? I see let's do, and is that let's do skip or let's do this problem?
You can
Yeah,
do it.
let's do it.
All right, let's do it. All right, what is the average rate of change, median home price? Well, we got a function, we got an interval, same dealio. In this case, our function is P. We're really looking at our change in P minus our change in time. And sometimes we have to be a little bit careful with our inputs, because for instance, I got to put something in this blank, but I know, for instance, T is the number of years since 2011. So if I'm interested in 2014 and 2017, I don't want to plug those numbers in, but maybe I'll plug in, what do we got? 6 and 3. And again, same thing, whatever my inputs are in for my numerator, that's going to be reflected in my denominator. And now is something I might need a calculator really quick. Or do you guys want me to just leave it as this and let you guys compute it? Or do you actually want to see what the number is? I'd like to see the number. Let's see the numbers. All right, so let's see, 3.3, 6 squared minus 12 times 6 plus 150 Looks like I'm getting 196.8. And for 3, what do we got? 143.7. All over 6 minus 3 is 3. And let's crunch that number. .1 divided by 3 is 17.7. On the nose. Oh, and the chat. Love rate of change. Let's do a problem. I'd like to see the number. Yes, plug in 6 and 3 into the not quite the derivative. So the derivative is what we're going to use if we want to talk about instantaneous rate of change. If I ever see the phrase average rate of change, that's where I'm going to be using the slope formula. So no derivatives at all. That's the difference between average rate of change and instantaneous rate of change. And yes, if I ever want to evaluate something like this, that's just going to be plug and chug that number into that formula.
I have a question. Can you explain where you got the 6 and the 3 from?
So I got the 6 and the 3 based on my inputs because I'm interested in, say, the years 2014 to 2017. But I want to remember what is my input. T is going to be the number of years since the start of 2011. So I don't want to plug in 2014, 2017, but I'm going to say that 2017 is 6 years after 2011, and 2014 is 3 years after 2011.
Okay, that makes sense. That's what I thought. I just wanted to see it in writing.
Right. Yeah. The trickiest part in a lot of these problems is really knowing what is the correct way to interpret our inputs and also what's the right way to interpret our outputs. So yeah, just read those questions super carefully. All right. I think that's about all we got for average rate of change. Let's scooch on down to maybe number 4 here, where we got a rocket ship launching off. Alrighty, so we got a rocket ship that is launching off the top of a 65-foot building, and we have a function that models its trajectory here. And we want to say that this function is representing either our position or our height off the ground, and t is going to be in seconds. And again, I want to keep track of these units because I got to do something with them here. Oh, and I guess we're not doing anything different. So we're still doing average rate of change. And since I want to say what's the average rate of change here, I want to be using that formulas again. And I'm interested in the height of the rocket, which means I'm going to be using my function h of t. And I'm interested in between 3 and 5 seconds. So just as before, I'm going to set up the equation h of 5 minus h of 3 divided by 5 minus 3. And again, just as before, if I want to compute h of something, all I'm going to do is take that something and plug it into that formula. Should I go ahead and compute that, or you guys think with that Desmos calculator on the exam you can handle it? Got
Yeah.
it. Alrighty. So maybe I'll say, let's leave this as an exercise, or maybe even better, I'll just say computation, plug and chug. But maybe we'll say, let's talk about what the unit is going to be. And in general, if you ever see something that's rate of change, like we've highlighted here, the answer of the unit is going to be something per something. So even just like looking at our answers, I can see it's got to be A because that's the only something per something I see. But again, I can also see that the answer is in our quotient here, that h of t is measured in height or in feet, and our denominator is the difference in seconds. So I see that our quotient is going to be measured in feet over second or feet per second. So usually the units, the answer's in there somewhere if you set it up correctly. But yeah, feeling good with some rate of change. Maybe let's toggle over to number 5. I'm not sure what that is. Limits. Here we go. Limits from a table. Yuck. Yes, I would agree, Allison. These are seldom my favorite problems either, but these number line or numerical value charts, they're really good to get intuition. So maybe a trick here I might recommend if you guys want a little trick to save some time with these types of problems. Travis says the answer is 9. Probably. Yes, the answer is 9. But in general, if you want to do these with a table, instead of like maybe filling out the whole chart, oh wait, no, it's -9. Typically what I would say, I mean, of course, here's our limiting value. I would typically say if you're going to compute these, just look at the values, maybe either to the left or to the right. Typically, you don't need to do the entire business here. If you just do the one immediately to the left and the one immediately to the right, if they're really, really close and there's a nice number in between them, more often than not, that's the answer. So maybe let's just go ahead and plug in these two guys. And let's just see what that gives us. And all right, let me just jot something down really quick and I'll compute these numbers. +4, x -5, -4.001. So if I plug it in from the left, it looks like I'm looking at -9.001. And if I do the same business from the right-hand side, looks like oh, wait, looking at, excuse me, -8.999. And so in general, I can fill out these other guys, but most of the time, this is usually enough data to figure out what's the nice thing in the middle. And is there a nice number between -8.999 and -9.001? The answer is yeah, probably -9.
-1, yeah.
And typically, yes, I might need a little bit more information to figure out the left and right hand limits. But again, typically, if there's a number that's nice and in between all of them, that's going to be good enough. And if you guys do want, I guess I can rattle off the other values, since it's actually a very well-behaved function. Typically, there won't be a nice pattern just like this, but in this example, there is. But again, you can sort of gather where my values are going from the left, where they're headed from the right, and what we're really attacking in the middle. Any questions? Quick general question. How do you access the calculator in Infinity? Here and in the HonorLock exam. So we have a couple of approved links that you can access in Infinity. Whereas you won't actually close, excuse me, HonorLock. You won't actually close HonorLock, but you can open another tab. When you actually enter the first screen that you see before you actually start the exam will have those lists, those links provided. So you can actually click on those, open them ahead of time. But if you actually open the exam, start doing problems, there's a little drop-down menu. I need to remember what it says. I'm going to send you guys an email tonight, another Canvas message. I know you guys have been getting a message from me almost every day, but just one more, I promise. But there's a little drop-down menu that I think says exam information. And if you click that, the links will be there and it'll take you to the Desmos Scientific or Desmos Graphing Calculator. So I promise you will be able to access those during the exam. But I'll include all of that in an email that I'll send tonight. Maybe I'll say one more quick thing about this particular problem. Because if you guys are really not jazzed about doing these sort of tables, because I know certainly I'm not, what you can also do to compute these limits is use a little bit of algebra. In general, a little bit of algebra goes a long way in this course. Um, And maybe I'll just say as a rule of thumb, if you're ever computing a limit of a nice, single line expression function like this, the first thing you should always try is, can I just plug in the number? And you notice really quick, I can't plug in -4 because that's going to give me 0 in the denominator. But if you check, that's also going to give you a 0 in the numerator. And if you ever get a 0/0 situation, more often than not, that means there's some cancellation that you can get if you get some factoring. And indeed, in this case, if you actually go ahead and factor that numerator, you get exactly that, and you get some sweet cancellation. And this is totally fine because we're talking about the limit as x approaches -4, so we're never actually going to get there. So the limit of this guy is actually the same thing as the limit as this guy. And that's another quick way that you can get -9 across the board. But the function table is good, just get some intuition. And Travis, that's what you did. Excellent. Emily's got another question. Once we turn on the honor lock and open the exam, we can go into Canvas and use the Desmos link. So you won't be able to go into Canvas, but you will have the links in the Affinity page within honor lock. I think maybe Canvas is one of the approved links, but Desmos definitely is. And like I said, there will be a little drop-down menu. I can't remember off the top of my head what it says, but I can pull up the Affinity and I'll include that in that message tonight. But yes, I promise you will be able to use your calculator. Alrighty, so we got some limits. Yeah, okay, limits from a table, limits from a graph. So let's do the same business here. There's going to be a graph on the next page, and we're going to use that to compute some limits. So maybe I'll switch over to this page, and I want to use this graph here and try to compute some limits. And for a question like this, I actually want to sort of think about doing what we did in the previous example, as approaching that limiting value ever so closely, using values just very, very close to it. So for instance, if I talk about, say, 2 here, right here on my chart, I really want to see what's going on with this business. And I really want to think about this as a roller coaster, or I'm driving along these curve, and the limit is going to be where I think I'm going to end up, whether I can see or not that I might drive into a hole. So for instance, if I approach 2 from the left-hand side, I want to ask myself, if I get closer and closer and closer, taking values like 1.9, 1.99, 1.99999, where does it look like the function values are headed? And what would you guys say? Drop it in the chat if you got it. Let's see. So Christian, you're on the right track, but that's where it looks like the x coordinates of my points are headed. But really, for the limit, I'm actually interested in where the function values are headed. So you're absolutely right. My x values are going to 2 here, but I really want to ask myself, where are my y coordinates going? And now you got it. Yep, it looks like I'm heading up to 9. So limits are all about where you think you're going to end up. Again, it's like I'm driving in this really thick fog, and where I think the road is my limit. And again, maybe the fog is so heavy I can't see that I'm about to drive into a hole and, off this cliff. But if we play the same game, approaching 2 from the right, taking things like 2.1, 2.01, 2.0001, I want to ask myself, where does it look like these coordinates are going? And I might say the same thing or the same logic. It looks like I'm heading to y equals 4. And once I have my directional limits, now I can ask myself, do they agree? And if they do, that is the limit. And if they don't, then, well, DNE. And this is pretty common if you ever see a question or a function like this that has, this disconnect. And again, it looks like if I'm driving, taking my car, I'm going to drive off a cliff here. So that usually tells me that there's disconnect or the limit can't exist. Nice. Let's see. So we've talked about limits from a table, limits graphically. I guess number 7 here is a little bit more limits, but maybe a little bit more of an analytic flavor. Should we move on? No objection. Excellent. And again, we got a little bit of text goofiness here, so maybe I'll just erase this. Can everybody understand what the piecewise function is? I can rewrite it.
Yes.
Yes, rewrite it. Excellent.
No, we can
Oh, you
understand.
got it. Okay, cool. Just checking, just checking. So what do we want to do here? We are interested in the limit as x goes to 3, and we want to choose a c value appropriately so that that limit exists. And so the name of the game for a limit existing is, what can I do so that my left limit agrees with my right limit? Well, let's start with that and say, I think there's enough room here. Let's say if I can compute my left-hand limit. And let's see what we can make of that. And the question is, a piecewise function, 2 disjoint pieces, if I'm going to approach 3 from the left, which piece of this puzzle am I going to use? The first guy or the second guy? Well, the answer is always going to be here in how I accept my inputs. Because if I think about approaching 3 from the left, I'm thinking about numbers like 2.9, 2.9, 2.9999999, and all of those values are going to be less than 3. So if I take the limit as x goes to 3 of this whole function, that's the exact same thing as taking the left-hand limit of just this first piece. And luckily, that's just a nice single value function. That's something we can compute. And once again, with limits, if there's no objection, it's a nice single line function. It's not piecewise, and I am able to plug in the number. That's going to be my answer. So if I let x go all the way to 3, 3 over 3 is going to be 1. So maybe I'll call that c plus 1. Do we agree with our left-hand limit?
Yes.
Excellent. No objection. So let's do the same thing with our right-hand limit. And then we'll see what has to be true for them to match up. And if I do the exact same logic, I'm approaching 3 from the right, 3.1, 3.01, 3.00001. All those numbers are bigger than 3. So I'm going to use that second part of the function. And again, once I'm here, single line, no objection. I might as well just plug it in and roll with it. And -3 plus 6 sounds like 3. And so now that I've got my left-hand limit and my right-hand limit, if I want this limit to exist, these two guys have to agree. So the only way that this limit can exist is if c plus 1 is equal to 3, which tells me that c has to be equal to 2. And a great way to double check your answer on these types of questions is to say, plug in that value that you just found into here, and then do the same thing again, check that they actually do match up. Alrighty, let's scooch on to maybe number 8 here, which looks like another piecewise function with a limit. Let me just double check. I'm just going to scroll to the other page. Okay, we wanted to set up a function, then do the same business with the limit. So maybe we'll just set up the function really quick, and then the limit was actually not too bad. How's that sound? Awesome. So Yeah, I'm kind of bleeding for space here, but actually, luckily, I think this is actually a kind of one-liner. I'm gonna write this B of t. And what we really want to do here is look at the situation and set up a piecewise function. And I say, I'm paying this monthly bill for my cell phone. Things are good. I've got a low cost plan. Geez, $70. For a while. And then it looks like I'm going to jump up to 105. And so I want to say take t to be my input, and it's going to be time, but in months. But I want to think about it as representing the number of months after January. So t equals 1 is January. January is the first month. And since it looks like my little box is covering up the problem, that my rate is going to jump up in May, it looks like I really want to consider two inputs where t is to the left of May or t is after May. And I know it looks like these signs, where do I decide to put the equal sign? In general, that doesn't matter so much for the limits. So don't get too hung up about that. But maybe if I want to be completely pedantic, it should be the other way. Just because I'm assuming when my rate jumps up in May, when t is equal to 5, I'm paying the more money. But I just need to check, with these parameters, when I'm before May, how much am I spending? How much am I paying May onward? Well, the answer is just $70 for January, February, March, and April. And May onward, I'm paying $105. Do we all see how we set that up? Awesome. So maybe I'll just rejot that over here. And geez, I already forgot what I wrote. But if you do the same business with the limits are in this case even easier because these are constant functions. So the limits would just be the values. And you can check if I do the same thing, take the limit of that leftmost constant, I get 70. Same thing with the rightmost. And in this case, those two figures do not agree, so they cannot be a limit. And this is very, very common if you have any sort of situation where you're paying some sort of rate and then in an instant it switches to something totally different. Most of the time, there's no limit there. Let me just check the chat. DNE, yes, the easier one. Yep, cool. So again, once I get the piecewise function, the not function isn't too, or excuse me, the question's not too bad, but it's sort of setting it up. That's typically the hard part, but that's life. All right, so it looks like we've graduated from limits and we're now on to derivatives. And again, you can kind of see, again, I can't divulge exactly what those 13 magical problems are going to be, but as you can sort of see the themes that are evolving, multiple questions about certain types, you can sort of guarantee that there's going to be one average rate of change. It's probably going to be like one of those 4 we did. There's going to be one limit question. It's going to be like one of the ones that we just did. Same things for derivatives. And it looks like 10, 9, 10, 11 are just straight up compute the derivative. So let's do it. And so maybe I'll swing this up here, give myself a little more room. And if I just want to find the derivative of something separated by addition, subtraction, the great thing is I can just go down the line, do them piece by piece. Oh, question for the practice exam. From a question bank, yes, I think everybody should have different questions, different randomizations for their practice exams. Or maybe I should check. Do you guys have these exact same numbers? No, okay, that's good, because if you do, maybe I shouldn't be doing it. Or who knows? I don't know. I don't care.
I just checked question 9 and it's different for me, but it's
Okay, good. That's
it is a derivative question though. So
right. They should be the same types of questions, but with different numbers. And that should also happen with the actual exam. Same types of questions with maybe some numbers randomized. Like randomized in a sense that like they're not going to be any easier or harder than the others. Like not that like somebody's going to get a number of 0 and somebody's going to get a number of like 12 million. Just some like randomized integers and things like that.
Yeah, like when you click the practice similar question on the
Yeah,
it shows
exactly.
like a similar question with a different number.
Precisely. Yep, but in here, this type of question, I've got 3 quotients and we've got an option here. I could run the quotient rule, but the quotient rule is kind of the worst rule. So I'm going to say maybe a good strategy is the first thing. Let's rewrite this function using some negative exponent magic. So that we can use the power rule. And this is typically much quicker to use some of these negative exponents, then do the differentiation, then put things back the way you found them. Power rule is your favorite. Power rule is the best rule. 9 and 10, 11, some business there. Yeah, okay, cool. So let's just do a quick diff. Running the power rule super quick, bring down that exponent, let it hit that coefficient, take 1 away. Maybe I'll do the same thing here. I'm a little, wary about negative, so I'll just do a quick intermediate step, and then I'll do the algebra later, because I don't want to make a mistake with my signs. And maybe same here, just to be super cautious. And if you need to, do a little extra intermediate step, then save the algebra. If you can separate the calculus and the algebra, do one more intermediate step, it will really save you a lot of your common mistakes. But regardless, let's do that algebra step right now. -3 times -12th. Maybe I'll call that negative 1/4 or plus 1/4. How about -40 x to the -6th? And if you're not a big fan of negative exponents, we can put everything back the way we found it.
The test should take both answers though, right here, right?
I believe so. It should.
Okay.
I need to double check, unless it specifically says do not have negative exponents in your answers, it should be fine.
Sounds good.
Awesome. All right, well, let's check the chat. Powerful 1/4, negative exponents. Yes. Okay. Excellent. Number 10, similar story, except we don't need to do the business with the negative exponents. Should we skip it?
I'm good to do it. This is one of my favorite ones, so it should go.
All right, yeah. Let's just do it piece by piece. I'll say 3 comes down, hits that 2, makes 6. 3 minus 1 is 2. Same thing here. 2 comes down, hits the 18, maybe makes 36. 2 minus 1 is 1. Same thing with 45x, because I can, of course, treat that as x to the first. Take 1 away, I get x to the 0. X to the 0 is 1, so I just get that constant. And of course, that -12 is going to vanish, it's constant. Or you could call it -12 x to the 0, bring the 0 down. 0 times anything is 0. However you want to slice it. Right on. Number 11 here, since we're entering into some chain rule, maybe I'll switch over to my other screen. Let me just jot the problem down real quick on a piece of paper. So then I can switch screens and it'll be a-okay. All right, let's give ourselves a little bit more room here. I'm going to switch over to my office hours good notes. And let's say we want to take a look at the function. I just wrote it down and already forgot it. Minus the square root. X cubed minus 5x. Alrighty, let's do it. And of course, the objective here is just to find the derivative. And just as before, I've got two terms separated by subtraction here. I can handle them individually. So let's do that. And what I need to realize here is that in both cases, I've got compositions of functions, which means I really need to be thinking about using the chain rule. So for instance, this first dude here, I've got e to the something. And the chain rule is going to say, well, the derivative of e to the something ought to be e of that something, because I know the derivative of e to the x is e to the x. It doesn't change. But then the chain rule says, hang on, pump the brakes. You still need to multiply by the derivative of that something. Exponentials are a little bit tricky to see the input and the inside function, the outside function. Typically with chain rule, what I really like to do is this little ddx step for the inside function. That's typically to prevent myself from trying to do too much at once. And that's honestly where many of the common mistakes come from. All right, so we feel good about that. And then maybe perhaps I want to scooch on down to the square root function. And I might say, hang on, a good strategy for square roots is like the negative exponents is to turn that into an exponential. So maybe I'll just drag this guy and drop it down. And maybe we'll say we'll rewrite our function to the 1/2. And that way I can enjoy the power rule with that guy. So maybe I should have done that beforehand, but it's totally a-okay, doesn't matter so much. And now once I'm here, it's going to be the same business. I've got an outside function, I've got an inside function. Let's run the chain rule. And the chain rule is going to say, well, something to a power, apply the power rule. 1/2 comes down, take 1 away. I've differentiated my outside function. I still need to evaluate at my inside function. And the chain rule says one more step. You got to multiply by the derivative of that inside function. And again, I'm just going to use that brief ddx notation just to give myself a breather, and then I'll take care of the inside function differentiation in another step so I don't try to do too much or forget anything. And again, I just want to keep going down the line, differentiate until I can't differentiate no more. That piece is fine. The derivative of -3ex is -3. Taking away 1/2. This dude to the -1/2 power. Maybe I can deal with that when all is said and done. And I can differentiate this guy just using the power rule. It's a polynomial. And whereas that is my answer, I might want to clean it up a little bit. So maybe just a little dash of algebra in case I need to do something with my derivative. And once I'm here, I might say I've got a negative exponent that's going to go in a denominator. Maybe with this 2 here, that's in the 1/2. This guy is just multiplied, so it'll go in a numerator. So maybe I'll say -3x squared minus 5 up top, divided by 2 times either to the positive 1/2 power, or I could just call that a square root. And that looks like it's about as good as that's going to get, so we'll put a box around it. What do you guys think? Chain rule, what do we feel?
Yeah, these are the tougher ones for me. It's a lot of steps, so that's why I always ask, like, would it be okay to stop if the test doesn't specify on the answer above?
Yeah, you should be okay with this. It will understand negative exponents, and if you leave it in a product like this, totally a-okay.
Okay. Cool.
Again, unless it specifically says don't leave negative exponents, but I don't think the problems actually say that.
Yeah, I think this is one of the ones I have to practice like 10 times to let it like really sink in.
Yeah. The important things are to, again, if you need to, put your function in a form where it's able to be differentiated more easily. Doing these sort of power tricks or negative exponents, whatever will make your life easier. And another thing, and I know I've said it, I'm a really big fan of this business with the chain rule to try and not do too much at once. I mean, the 90% of the time when somebody makes a mistake, it's because they're trying to do so many things in one line, and you forget something, or you forget to write down the X or whatever, or something, or drop an exponent. We don't have a limit of how much scrap paper you use for the exam, so use however much paper you need. Yeah, don't want to make anybody to make a silly mistake. Cool. If there aren't any questions, maybe we'll switch back and see what's next.
Yeah, Matt, I got a question.
What up?
Um, just based on what I'm looking at, could I mean if you're technical enough, could a shortcut have been used, or is this just based on this problem?
When you say a shortcut, what type of shortcut do you have in mind?
Just number placement for what I'm seeing. Like you have the original question, and you can just move numbers around for it.
Yeah, I mean, if you have seen enough of these and you know, like, oh, this part goes here, that part goes there, and you trust yourself enough, go for it. For me personally, I don't trust myself enough. Like, if I was going to do this problem, this is exactly how I would set it up. Rewriting it in one step, and then setting it up, doing each chain rule individually. But that's just me.
Well,
But
I
yeah,
don't trust myself with the chain rule. That's why if I've seen enough, if the like a shortcut exists, I mean, I'll have to see if
yeah.
it would be
I mean,
possible.
like once you get like really good, like maybe you don't need to do this intermediate step and you can go just from here to here.
Hmm.
That's totally fine. For me, I really like this little setup step because things that I do all the time is like I forget like these like little negatives. I turn things that are negative to positive. But if I like rewrite it, I'm less likely to do that. That's just me. Find whatever works for you.
Yes, sir. Appreciate that.
Yep, and I see Allison, you've got a question. Yes, loose leaf paper is a-okay, and we do not need your scratch work, so yeah, use whatever you need. I would say yeah, use loose leaf paper. Don't use a notebook. Just because the good folks at HonorLock will, if they see a notebook, they're gonna like pause your screen and say, "Are you using notes?" And they'll get all uppity, and then they'll tell me, and don't let that happen. Just scratch paper. Cool. Alrighty. Here we have another question. And let's just put a little check mark here. Is graph paper okay? Graph paper is excellent. I've seen people using graph paper, printer paper. My favorite was last time because I get all the recordings, was seeing somebody who used post-it notes. So whatever you need, just as long as it's paper. Don't use like a tablet or anything. Just pencil and paper or pen or whatever. All right, the number of MyBook members in millions. Anytime you see something like that, a unit associated to the inputs or outputs, especially a quantifier, maybe make a note of it, can be approximated by this function. T is the number of years since 2010. Another thing, we got to modify our outputs, but also our inputs. And we want to know how is the number of chain members, changing in the year 2017. So a good indicator you ever see the word change in a word problem, that means there's a derivative floating around somewhere. So if I want to find the rate of change in a particular year, let's start with a quick diff. Run our favorite, the power rule. 2 times 35 is 70. Minus 73. And that 102 drops off because it's constant. And now the question is, if I want to find the number of members changing in the year 2017, am I going to plug in 2017 into that function?
No, 7?
We're going to plug in 7 because I want to be careful with my outputs, knowing they're in millions, but I also want to be careful with my inputs, knowing they're the number of years since 2010. And we got to do some math. 490. That sounds right. Minus 73. What is that? 417. And the question is, what is the unit that we associate? Well, an average rate of change, we know it's there's a quotient and we can see that. And really the same thing is true for derivatives, but really we want to be thinking it's the change of this function, my output, versus this input. And so the only thing I need to ask myself is what are my outputs measured in? Well, they're in the number of members in millions.
Is it million members per year?
That's exactly it. And T is the number of years. That's right. And if we really want to be pedantic, we would say the 417 millions of members per T years after 2011, or just years. And again, the unit for a derivative is always going to be something per something. So even if you just remember that, you can see that you're going to eliminate A and B. So a nice little trick, that the derivative of the unit of a derivative is something by something.
Do we get partial credit for these if we get the unit right, but the number wrong?
Yes. So the way that the grading happens is very similar to your homework, that if you get like this wrong but that right, you'll get credit for the right, but not for the wrong.
Okay, that's good to know. I have a question about this problem because this seems like it could be an easy one if you remember to start by pulling the derivative. What is it in the word problem that tells you like, okay, I have to get the derivative from this?
The key word is change. If you ever see the word change or changing in a word problem, and it's not average rate of change, if it is average rate of change, it'll actually specifically say average rate of change or over an interval. But if I ever say, how much is this quantity changing at this moment?
Mhm.
That's a derivative. That's instantaneous rate of change.
Okay, that makes sense. So if I see average rate of change, then I go with the average rate of change like formula.
That's
And
right.
if I see changing, like how it's worded here, then I can
Yep.
grade.
Right. The only other way you'll see average rate of change is kind of like oh, where's the soccer game problem? That was on here. It was like number 2. Oh, here it is. Where I want to find the rate of change. Um, it's just says rate of change, but it
Yeah.
says over an interval.
Mhm.
And if it's change over an interval, that's average rate of change. If it's change at a specific moment, like how much is the number of members changing in this year at this particular moment, that's instantaneous rate of change, and that is the derivative.
Wow. That's like a play with words.
Yeah, so that's why, like, when I read a word problem like this, I know it's a little different. It's on the computer screen, but like if this was like a paper test, I would say highlight those words, like especially, or like make notes, like even on your scrap paper, just say outputs in millions, input years since 2010, and like say change in 2017. That's derivative at the t value corresponding to 2017. Just to kind of make those connections.
Makes sense.
Yeah. Any other
Yeah.
questions?
Yeah, I have a question.
What up?
So just for my own edification, because the word problems are providing context for the math that we're doing, to reiterate kind of what you were saying, the games per year for the soccer would be like saying, oh man, our team is doing horrifically because in these years we've been losing like 3 games more every year kind of thing. Whereas here, if we were talking about the MyBook members, it's irrelevant how we got to 417. This number now, we've got to 417 in this year. It could have been like a monumental exponential growth, but you're saying in 5 years we got to 417, which is amazing. You're talking about in instance, you're saying.
That's right. The way that you can sort of think about like average rate of change versus instantaneous rate of change, because like, this is not like a go-to example. This does not pop into my mind automatically. But what does is imagine like you're driving a car and you can say, oh, I drove 100 miles in, I don't know, 60 minutes. And you can say, okay, I drove 100 miles an hour overall. Okay, that's way too fast. But you can say, over the span of this journey, I drove this many miles over this much time. That was my average rate of change. Maybe I sat in the driveway for 15 minutes and then revved it for the rest of the time. But overall, this entire journey, that was my average speed. But what you can also do is say, during that journey, I'm driving. If I look at my speedometer right now, I can see this very moment I'm driving 60 miles an hour, 70 miles an hour, however fast I am. So it's sort of like, what is my speed right at this moment? Or what was my average speed over the entire journey or the car trip or whatever?
I got it. Yeah, that makes a lot of sense. Awesome, awesome. Thank you.
Yeah, and I feel like these, especially these types of problems, you need some sort of analogy that you can put in your head. Like with the limits, that driving in a thick fog, that's most of them are like car analogies for me. I don't know why.
Yeah, I love that. Got it.
Yeah. Okay, cool. Should we keep jamming?
Ready to go.
Let's do it. Alrighty, we got some more chain rule problems. Maybe let's just say for the sake of time, we'll do one of these. They're actually very similar. This one reduces to the case of this one. Should we just do this one, number 14? Let's do it. Because you'll see after maybe my first step, I can actually get into the situation of this guy. Because again, if I ever see a number divided by something, always use negative exponents. It's just way easier. Now, if there had been like a function or something here, I would be forced to do the quotient rule. But because this is just a number, I can just do a little trick and change this to a chain rule problem. Oh, -7. And now you can see I'm in the exact same setting as like this problem. But once I'm here, I can say I want to find the derivative. It's a composition. I got an inside, I got an outside, got to run the chain rule. First thing I want to do, if I've got something to a power, probably want to use the power rule. So maybe I'll say -7, yank that out front, take one away. And what does the chain rule say to do? Plug in the inside function, but also multiply by the derivative of the inside function. And again, for chain rule, I like to do this little setup step. You don't have to, just helps me out to not forget anything. And we just crunch the numbers. And the derivative there, maybe -2x. And then either I could leave my answer as is, or maybe I could do a little bit of rearranging. Say I got something to a negative exponent, let's throw that downstairs. And maybe I'll say -2 times -7 is +14. And maybe I'll put that in that blank. So these kind of quick tricks that you can do with the chain rule, especially if you see quotients and you don't want to use the quotient rule. If your numerator is just a number, think about using some negative exponents. And again, if there had been a function up top, I would probably have to use the quotient rule anyway. All right, right on. Should we do a word problem?
I have a quick question for this
Yes.
one. It's probably a silly question, but what happened with the dy dx on this one?
So with this, that's why I like this DDX notation, is because this is actually what we call an operator. This is telling me what to do. And this is saying take the derivative of this and then multiply. So this guy became this guy.
Okay.
So yeah, that DDX, like I said, it's an operator, it's an operation, it's something you do. And the reason that we call the derivative like dy dx is because that's what we get by ddxing y. So we
Okay.
just throw it up to the numerator.
Okay. Okay. That makes sense.
Yeah, it's funny because like they're not really fractions, but also they kind of are. It's a weird mix. It's where kind of the math theory gets a little weird, but for
Yeah,
now they're
from
similar.
algebra, that's like kind of trying to wrap my head around this stuff.
Yeah. Yeah. So again, this is just the notation I like to use to tell me what to do. If you don't like that, what you can also do is you can write how about times 4 minus x squared prime.
Okay, yeah, I like that one better.
Okay, yeah. For me, I like drawing this big blocky DDXs. I'm never gonna forget it. Whereas sometimes step to step, I can forget a prime.
Yeah,
But
that's good advice too.
yeah, totally whatever works for you, as long as you remember what you gotta do. All right, let's do number 15 here. Looks like I like this, Mandora and Electrify instead of Pandora and Spotify. That's fantastic. All right, so we are projected to grow given a model. F is going to be measured in billions. I'm just going to underline that because I see I want to do something, understand what my units are. And T is going to be the measured in years. Where I'm given a starting point, number of years after 2011. And just as before, I want to find what is the amount spent or how quickly the amount was changing in a particular year in 2013. So if I think about what this means, or just maybe just jotting down what I need to do, certainly I need to find f prime of something. And the reason I know how to do that or know to do that is because I'm asking how fast something was growing or changing. They might use words that are like decreasing, increasing, growing, shrinking, anything that represents a quantity changing. That means you're going to use the derivative. And if I want to figure out how much that was happening in 2013, that's where I'm going to remember t equals 0 is the number of years after, or t equals 0 is 2011, or t is the number of years after 2011. So maybe I would say find f prime of 2. The most important thing to do with a word problem is figure out what you are looking for. And then once you've found that, then you can find it. So let's find f prime of t. Well, maybe I'll just rewrite f of t. Do a quick diff here. I know the derivative of 3.8 is going to be 0. It's a constant. And when I ever differentiate a natural log, I always want to be thinking, if it's not natural log of t, just plain old the variable, I got to use the chain rule. So in this case, I know the derivative of ln of something is going to be 1 over that something. But then maybe the chain rule says, hold on, you also need to multiply by the derivative of that something. And in this case, that's not a huge deal because, of course, this is equal to 1. So if you had forgotten that, you would be fine for this problem, but just keep that in mind, that the chain rule is always working in the background. And once I have that, I know what f prime of t is. The only thing left to do is plug in my value, simplify if need be, and roll with it. And I guess perhaps I need to ask myself, well, what is the unit? Again, I know it's got to be something per something. So at least I know it's not B. And the only thing I need to check is what were the units that I underlined. Well, F is in billions of dollars and T is in years. Understand those inputs and the outputs. Feeling good?
Yes, sir.
Excellent.
I think what confuses me on this one is like on that second step for T, I want to put in 2. I don't know why I want to do that.
Going from here to here?
No, on the second line right there where it says 3.8 plus ln plus T plus 2. Yeah.
Oh, yeah. So
want-
here's where we need to sort of be careful. And again, it's sort of figuring out what is the object that we want to look at, what we're looking for, or what we want to test. Because the answer could be, the question is, how much money was spent in this particular year, in which case I'd be like, f of t is telling me how much money I'm making, so that's my guy. But if I ever see the phrase like how fast growing, how quickly it's changing, these are the indicators that I want to use the derivative. And it's tricky. Sometimes they can be very deceptive and sneak these words in there. Because again, I said if you see the word change, that means derivative. But there are also these synonyms for change that can really be the red flag that you want to look out for.
Okay, good to know.
Yeah, so if you ever see growing, shrinking, increasing, decreasing, how fast something happens, usually that's telling you there's a quantity that's changing that you're trying to measure, and the first derivative is how you measure that. So we've got number 16 here, which is a similar flavor where I want to actually differentiate this guy and plug in a value. Do we want to do it or do we want to skip over so we can get to like optimization or related rates or things like that?
Yeah, can we do this one? This is actually one of the ones I'm stuck on in the practice.
Yeah, let's do it. Let me move my little box out of the way. Let's see, let me just read this real quick. I think I can squeeze it into here. I know like my PDF download is like kind of compressed everything, but we'll see if we can do it. So we have a setting where I deposited some money that's gaining some interest, compounded continuously. The nice thing about this problem is usually for these types of like continuous compound interest problems, we have to actually set up the equation. This one does it for us. It says, I've got this input, I've got a rate, but it's going to be modeled by this formula. And if I've got the formula, that's all I need to look at. Not to say this first line isn't important, but it is kind of a red herring. So if I say I want to calculate the rate at which something is increasing, and again, the big words here are rate and something is increasing, so something is changing. And I want to find how quickly it's increasing after 3 years. So the fact I see rate or increasing means I'm going to take the derivative of something. And since that something is the total amount, which is given by this function, that tells me I want to find p prime of something. And if I want to find that something after 3 years, that'll be p prime of 3 because I have no restrictions on my input. So once I've got that, the only thing left to do is do some differentiation. Maybe I'll scooch this out of the way. Uh-oh. All right, let's do it. So maybe I'll just re-jot down the function. P of t is 4,000, my principal. E to the 0.0385 t. And if I want to take a quick diff, that constant multiple, that's going to stick around. And all I need to do is differentiate e to this something. Well, I know the derivative of e to the something is e to the something. But the chain rule says, hang on, that's not enough. You must also multiply by the derivative of that something. And in this case, that something is my rate, written as a decimal, times t. So let's just differentiate that. Too many zeros. And of course, if I really wanted to, I could combine these two constants, but I can leave it as is and then say, then plug in t equals 3. And should we see what that gives us?
Yes, please.
Let's find out. 4,000 e to the 0.0385 times t, now t is 3, times 0. And we get, maybe I'll rewrite it here. P prime of 3 is equal to 172.855, which I'm going to write as 0.86 because it tells me specifically round to the nearest cent. And the only thing I need to ask myself is, well, what is this representing? It's a derivative value, so it's got to be something per something. And since it's the rate of change of this amount, which is in dollars, the value in my account, versus time, these 3 years, it's got to be in dollars per year.
Okay, yeah, this one makes sense.
Yep. And, we can sort of check ourselves because I can say, it's a positive number, which makes sense because my account is gaining interest. So I can see that things are going in the right direction. $172 worth of interest that I'm gaining per year. That kind of checks out, especially at a low interest rate. Cool. Let's see what's on the next page. All right. Now we got some product rule, we got some chain rule. It's great. So this one, just straight up find the derivative. Maybe we'll do these guys, both of them on a separate sheet if that's cool.
Sounds good.
Actually, I wonder if I can copy and paste into my good notes. Because wouldn't that be something? Oh. Paste. There we go. Let's at least do number 18 here. Yeah, I will warn you guys, I'm not the most tech literate, but I'm doing my best with the iPad here. All right. And we want to find f prime of t. And if I just look at this, do a quick analysis, and this is a great thing to do before you start any type of problem that looks a little complicated, look at like the steps that you can kind of predict that you're going to need to do. Because for instance, I see there's multiplication here. Probably I'm going to need to use the product rule. This guy, no problem. I've got a power rule. This guy, I might be careful because I got to use the chain rule. I got e to the something, and that something is not just a plain old variable. And so that tells me I want to be careful, use as many steps as it takes so that I don't make a silly mistake. We can do this, try and do this all in one go, but we got time. We got 75 minutes to do 13 problems. We already got scratch paper. Let's use it. So the first thing I'm going to do is I'm going to give myself a setup step. I'm going to say I like that DDT notation. I'm going to set up what the product rule says to do. Product rule says diff the first guy, leave the second guy alone, then do the exact same thing but reverse the roles. And personally, I like to do this for these big, crazy problems because if you look at it, finding the derivative of this sounds like a nightmare, but now I've broken the problem to some easy, bite-sized, digestible steps. So that's just me. I'm going to do it because I don't want to make a mistake in front of all of you. That would make me so ashamed. But now that I'm here, I've broken it down to easy steps. Let's tackle those. Can run the power rule here. 3 times 5 is 15. T squared times e to the 1 minus t to the 6th. That's my first factor, totally done with the differentiation. But let's move on to the second. And we'll say, well, how do I differentiate this guy? It's e to the something. I got an outside function of e. I got an inside function of 1 minus t to the 6th. That's our chain rule. The derivative of e to the something is still e to that something. But the chain rule says multiply by the derivative of that something. And I could use the DDT notation, but is it okay if I just write the derivative?
Yes.
Awesome. But if I wanted to be extra careful, I could put another setup step, but totally up to you. And I could say that's my answer, but again, a little bit of algebra goes a long way. Maybe I'll simplify just a smidge. Maybe I'll say 5 and -6 make minus 30. T cubed, t to the 5th. Maybe I'll call that t to the 8th. And a good thing to do whenever you run the product rule, particularly with an exponential, is you're always going to get a common factor. It's a good idea to yank that out. In this case, it doesn't matter so much, but if I ever needed to do something with my derivative, like set it equal to 0, find the critical points, do anything, I'd want to be in a factored form. So certainly I could yank out e to the 1 minus 6. I can probably also yank out a 15, maybe a t squared if I so desire. But this is not totally necessary. But again, if I wanted to say find the critical points being on a factored form, I would just say t equals 0 and t equals whatever the 6th root of 1/2 is. What do we think?
Yeah, I think this is another one. Anything with chain rule for me, I gotta practice because it gets tricky. I think it's just a lot of like, one-off cases.
Right, especially chain rule combined with any other derivative rule. It's always very, very tricky because you need to be sure that you do things in the right order. Like you have to make sure in this case, do the product rule, and within that, you're doing the chain rule, not the other way around.
Can you walk us through how you did that in the first 2 lines there?
Yeah,
Real quick.
I guess the two things to realize, is I've got a composition and I've got a product. And the thing you should ask yourself is kind of which one comes first? And the answer is really this product because that's really involving the whole thing. The entire expression is a product, but only this one piece is a composition. So you kind of have to sort of look globally and then you can specify at the individual pieces. So since I see, product rule, chain rule, which one do I do first? I would say the whole thing is a product. Just this guy is a composition. So I'm going to work my way globally to locally.
Okay, and then the next line is just you getting the derivatives of each one.
Yeah. And like, so in that
Fine.
sense, once I've made up my mind, I'm going to do the product rule first. And then within that, I'm going to do the chain rule. That's where I like to do the setup step. I'm like, this is me writing out what the product rule says to do. And this is me doing it.
Okay.
And I use the chain rule right here.
Okay.
Yep, so it's kind of like you got to come up with a plan of attack first and foremost. Should we scroll on to number 18? Which is this quotient rule question. Should we do it?
Yes.
Let's do it. Let me see. Yeah, I'll get a new page. Maybe I can still copy and paste. Hey, look at that. Yeah, let's do number 18 here and I'll just rewrite it. And again, I look through this. I'm going to make a plan of attack. And I can say, okay, the first thing I noticed, I've got this big old fraction bar here, and it's some function over some function. I can't do my negative exponent trick. I gotta use the quotient rule. There's no way around it. And I say the whole thing is a quotient, so I'm going to do the quotient rule first and foremost. And within that, I've got these two guys, but they're both polynomials, so I can use the power rule. So I've decided I'm going to use the quotient rule, and within the quotient rule, I'm going to use the power rule. So now that I know what I'm going to do and how I'm going to do it, let's just do it. So certainly keep switching to eraser mode. If the derivative of a quotient is again a quotient, quotient rule is kind of involved. I'm going to write a quick setup step. Quotient rule says diff the first, diff the top, multiply by the denominator. Then do the same thing in reverse order and then subtract. Got to be careful with the quotient rule because the order does matter upstairs. And then throw that all over the original denominator, squared. I've written my setup step. I'm feeling good with it. Now let's just take care of these bite-sized pieces. Maybe I'll throw the product, excuse me, power rule of that first guy. I'll call it 26x. Diff that guy, 2 times 8 is 16. And throw that all over my original guy, squared. And again, once I've successfully done all the differentiation, it's time to do a little bit of algebra cleanup. Maybe we'll distribute these guys. I guess there's only one term to deal with there. And we'll see what we can make of that. 26 times 8 is 208 x cubed. 26 times 9 is 200 and 34. Jeez Louise. Thank you. Yeah, I don't have my calculator with me. And it is not a good day for mental math. 13 times 16. Oh my gosh. This one. Okay, I guess I do have wolf mouth right here. 208. How about that? And we got lucky. We got some cancellation. Doesn't always happen, but when it does happen, it's a good thing. And again, this is just a good habit to do because, you know, if I wanted to not only compute the derivative, but do something like find the critical numbers, this is really the form I want to be in. Because for instance, I can read off where maybe my first derivative doesn't exist. I see it has a critical number at x equals 0. Yeah, but if it's just compute the derivative, I think any of these would be fine. Alrighty, if we're feeling good, maybe we'll switch over to the next one, see what's in store.
Sounds good.
All right. So this one, number 19, is actually very similar to the oh gosh, the previous one with the interest one. Similar, I want to find a derivative and evaluate at a particular value. So for instance, in this case, if I just read through it, I want to find the rate of change. I wanted to be in red. Find the rate of something changing. What is that something? My profit. So I got to find P prime of something. And that something is going to be when 35 items are sold. So all we need to do is differentiate that guy. Do we want to do it?
Yes.
All right, let's do it. We will find first our derivative, or maybe I'll say what is our function, 25x. 1 minus 0.065x squared. And the question is, how do I differentiate this? I see two things. I've got multiplication. I see I've got a composition here. But what I see is that the whole thing is a product and only this guy is a composition. I want to work myself globally to locally, which tells me I'm going to start with the product rule. And within that, I'm going to do the chain rule. So maybe for the sake of time, I've decided I'm going to do that. Maybe I won't use the DDX notation. I'll say let's diff the first guy. The derivative of 25x is 25. I'm going to leave the second guy alone because that's what the product rule says to do. And then I'm going to say plus the first guy times the derivative of the second guy. And if I think about how I'm going to differentiate this guy, I see that's that composition we identified. It's something to a power. Let's use the power rule. And then we'll plug in the inside guy. Oops. But then the chain rule says you're not done yet because you also need to multiply by the derivative of that inside dude. And that's our function. Doesn't look like the nicest thing, but that's our function. And if we so desired, I could probably yank out a common factor of this guy, maybe even 25. Yeah. And then the only thing left to do is to plug in 35. Should I do that? See what the number is?
I think I'm good. You just plug me in 35 for X, right?
That's exactly it.
And then it should be dollars per item.
That's correct. It's the change in my profit, which is in dollars, versus the number of items. Correct.
Yeah, considering we're timed, I just want to do like the least amount of steps and get in and then get out.
Yeah. That's right. Do what you got to do. And again, like when you're studying for these, yeah, take the steps that what you need and do these things. Take the practice exam a couple times if you can, and try and keep track of your time. Because remember, you guys do get a retake. You get one retake. So be sure to leave some time for that. You'll submit your exam. Totally lost my train of thought. You'll submit your exam. It'll tell you you got these ones right, you got these ones wrong, and you'll be able to take a retake, one retake, and you can go back and check on those problems that you got incorrect.
Can
So
you
be sure.
tell me a little bit more about the retake? Because I've never had that before. So you finish the test, 70 minutes are done, and you get another chance to do it right after?
Right. So the 75 minutes are for both the exam and the retake.
Oh, okay. So it's only you can only take advantage of the retake if you have extra time.
That's right. So I usually tell people try to shoot for about 50 minutes, 25 minutes if you can.
Okay, that's good. See, I would have messed that up. I would have taken the whole 70 minutes and not had a chance.
Yeah, be careful. We had to like really change our wording in the syllabus about that because last semester or like my C session class, this is a B session half semester. I
Mhm.
teach another course that runs the whole semester. And a lot of people did not read closely enough. They thought they had 75 minutes for each, and no, it's 75 minutes total.
That's good to know.
Yeah, because I think
I wish they did this class as a C session.
yeah. Um, yeah. Um, I forgot what I was going to say. I think like the Infinity recommended amount of time is about 40 something minutes for those problems. It has like recommended amounts of times. I mean, some people you're going to be faster on some, slower on others. It's just like an average parameter, but I think the way that it's set up, we want you to take about somewhere 40 to 50 minutes on the exam and then about 20 to 30 on the retake. But yeah, it'll be fun. You get a do-over.
Cool. Yeah, that's like you get a second chance. I
Right, some redemption.
think you got a question in the chat.
Oh, I do. Is there supposed to be a power on the second derivative? Wait, we're not taking the second derivative in this problem. Oh, you mean the derivative of the second? Um, oh, you mean this guy? Yeah, there is a power. Because you did run the product rule, the power would be 2 minus 1 or 1. So you are right, there is a power there. There's always a left behind power. It's just whenever you bring down the 2, 2 minus 1 is 1, and we usually don't include that, but you're absolutely right. It is there. Yep. Cool, cool, cool. Let's see, what do we got here, number 20? So this one's gonna be a very similar, trying to find the rate of change in a particular instance. A lot of these problems are going to be modeled as find the derivative and compute at a particular value. For the sake of time, because we've already done a few of those, do we want to move on to like increasing, decreasing business? Things like that.
Yes, I'm okay moving on to something.
Okay, yeah, I just don't wanna like hammer the same things. I wanna like touch on a little bit of everything.
I feel like there's more graph stuff too that we haven't talked about.
Yeah, let me just cycle through.
I literally had to go to tutoring session twice for the graph problems because it would not. I almost emailed you because it wouldn't. I couldn't get the right problem following the videos, and
Yep.
I forgot what it's even called. I'll try to remember.
Yeah, some of the stuff can be tricky. How about we do some of this implicit differentiation related rates? How about number 21 here? And because I'm certainly going to need some, oops, some extra room. Let's copy that over. Come on. I just want to copy it. Alrighty, we have an implicit equation and we want to find the derivative dy dx. And see, these ones are a little tricky, but if you remember, implicit differentiation, all I got to do is play by the regular derivative rules and just remember that y is a function, then we're going to be a-okay. So this is where I really like to use that ddx notation because it really keeps you grounded, really keeps you on track. And the first thing to do is, I have this this implicit equation. The first thing you want to do is just differentiate both sides. So I just like to throw up a ddx, and that just tells me differentiate both sides with respect to x. And that's a theme that becomes more and more important to understand what is the variable of differentiation. So that's why this notation is also helpful. So the right-hand side, no secrets, just going to be 8, no y's to be found. For these guys, I want to be a little bit careful because for starters, I see I've got multiplication, x squared times y. I'm going to use the product rule. And here, even though I've got y squared, since my derivative or my variable of differentiation is x and this is y, whenever those things don't match, I need to use the chain rule because y is a function of x. So with that in mind, I'm going to run the product rule. Should I write out the ddx? Do you guys want me to take it step by step?
Yes, please.
All right, let's do it. And then I see Chris in the chat says critical points, inflection points up and down. We'll do that. We can do that after this. So let's say our product rule, diff the first, ignore the second, leave it alone. The first guy times the derivative of the second. And then when we get to the other guy, maybe I'll just put some parentheses just to separate them. I want to use the chain rule. So I've got 4. I've got something to a power. I got to use the power rule. 2 times that guy, bring down the exponent, take 1 away. The chain rule says you're not done because y is a function. ddx of y. And then on my right-hand side, no secrets. There's no y's to be found. So it's just the usual business. All right, do we agree with our setup? Excellent. So now let's take care of the smaller pieces. Derivative of x squared with respect to x. No y's to be found, usual business. x squared times d dx of y, and again, that's why this notation is important, because d dx of y is the same thing as dy dx. And if you don't like dy dx, you absolutely can use y prime. For me, I don't like to use y prime with y, because I'll either think of that prime as being an exponent or I'll forget it, and it gets kind of easy to make a mistake there. Whereas like these guys, totally night and day difference, but do what you prefer. 2 times 4 is 8. Y to the first is y. And again, dy dx is, well, d dx of y is dy dx equals 8. And once I'm here, smooth sailing, because I've successfully differentiated and I want to find dy dx. And I say, excellent, it's right there, but it's also right there. And our favorite way to turn two guys into one is to make it a common factor. But to do that, we might want to move everything else to the other side. So I'm going to say, let's throw that guy over there through subtraction. And then indeed, I've got a common factor of dy dx. And once I know what dy dx is up to a scalar, all I've got to do is divide, or excuse me, up to a factor, not necessarily a scalar. And of course, it's big, it's nasty, it's ugly. But that is our answer. And most of the time, your implicit derivatives will be some sort of quotient. Any questions?
No questions, just need to get used to using the dy dx, because you have a good point about messing up by using
Yeah.
prime. I felt more I understand the prime more, but it's really easier to mess it up. So I just don't
Yeah.
understand this
And
as
like this, we call this Leibniz notation, named after German mathematician Leibniz. It's kind of clunky, but that's kind of the beauty of it, is like you're not gonna mess this symbol up. You're not gonna confuse it with anything else. Um, and it's telling you everything change in Y versus change in X. Encodes a lot of information, and it's very, it's of course compatible with that DDX. Is thinking of the derivative as an operation, and how it's compatible with the other operations: addition, multiplication, subtraction, division. It's nice to have a symbol that's compatible. I like it. If you don't like it, totally up to you. As long as you have something in your mind that lets you distinguish the derivative from y. Yeah.
I also like the product rule way too much, and I probably would have done it on that second notation there where you have the chain rule. For
Yeah.
like I probably would have done the product rule on that too, trying to
I
rush.
mean,
Problem.
if you wanted to, you could say, maybe this is a little aside. If you wanted to say 4y squared, that's 4y times y, you could use the product rule on that. And as long as you're careful, you follow your nose, you'll get the same thing.
Okay.
Chain rule's a little slicker, a little bit easier and a little quicker, but yeah, it's it'll work. It might be a little messier, but you can do it.
Okay.
Yeah, so I see Chris asked in the chat, critical points, points of inflections, up and down. Should we do an example of that?
Yes, please. I think that's the graphing problems that I was having issue.
Yeah, let me just scroll through here. I know like we're kind of all over the place. Um,
That looks like one of them.
yeah, we got 29 here. I'm just looking. Acceleration number 3 is just second derivative nonsense. 29 is concavity. Blah, 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 blah. Should we just do, do you guys want to do, how about we do 24 here? But instead of critical points, we just do increasing and decreasing as well. Just kind of combine everything, do it a 2-for-1. Yeah, let's do it. Oh, where did it go? My goodness. Let's try that again. Copy. Also, I will say, because I know somebody's going to ask me like whenever we end, and I can stick around a few minutes after. We don't have to end hard right at 3. Happy to stick around, of course. But I know somebody's going to ask, can you share this with me? And I'm sorry, but the answer is I cannot. Just because these are actual review question problems, and somebody might have this variation, I can't, and I'm sorry. But regardless, let's look at this guy and say, instead of the critical points, we'll say increasing, decreasing the works. And I see I already erased part of it. All right. So we'll say f of x is 5x cubed minus 6x squared minus 27x minus 5. And you know what? Actually, this is a cubic. This should be nice. Let's do concavity on this boy too. Yeah. All stuff. It'll be fun. But let's say, I want to start with increasing, decreasing, critical points, increasing, decreasing, mins and maxes, the works. So of course, in that case, let's start with the derivative. And I'll say f prime of x maybe is 15x squared minus 12x minus 27. I got to find the zeros of this guy. Probably the easiest way is to get myself in a factored form. Looks a little annoying to factor, but luckily there's a common factor of 3 I can yank out. And I look at this looks mighty annoying, but will it factor nicely? 3 and 3? That'd be 5x something, x something. How about 1 and 9? Probably minus plus. You, Christian, you like the quadratic formula? That'll work as well. You guys also have the Desmos calculator. The graphing calculator will solve this, give you the roots. I like factoring. A factored form is pretty nice, beneficial, but whatever floats your boat. All right, but however we choose to slice it, we got the zeros. So of course we're gonna make our number line. Throw in those important numbers. And what I always like to do when I do this number line business, just because when you do things like increasing, decreasing, concavity, these points, there's these 3 things to get 3 people you talk to gain information: the function, its derivative, its second derivative. To keep myself on track when I'm testing, I like to put a little f prime. This is going to be a number line for f prime of x. So I'm just going to notate it. And now we need a couple of test points. Oh, I don't know. Let's be creative. I like -2. How about 0, 9/5 is just a smidge under 2. I could choose 3 if I want to be careful. It doesn't really matter. And this is where I actually really like the factored form. If you guys want to see kind of a slick trick.
Yes, we're all about the tricks.
All about the tricks. Excellent. Because one benefit of being in a factored form is that you can actually find these values very quickly. Let's say maybe I'll make my little chart. I've got -2, I've got 0, and I've got 3. Because for instance, yeah, I can compute things. This is my derivative. I don't really want to plug any of these numbers into there because, that might take me forever. But at the end of the day, I do not care what the number I get out is. I just care, is it positive or is it negative? And that's where being in a factored form is super helpful. Because for instance, if I plug in -2, I can say, you know what? 3 is a positive number. If I plug in -2 into 5x minus 9, -10 minus 9, -19, don't really care. That's negative. -2 plus 1, that's -1. Again, don't care. That's a negative number. Positive and 2 negatives, that sounds like a negative to me. And so that tells me lickety split, I have to be negative here, or my function f of x has to be decreasing. And I can play the same game with 0. 3 is a positive number. 5 times 0 minus 9, -9, whatever, but it's negative. 0 plus 1, that's 1. Don't care, it's positive. Positive, negative, positive, sounds like a positive. And if I plug in 3, 3 is always positive. 15 minus 9, 6, positive. 3 plus 1, 4, also positive. Wait, did I make a mistake? Oh, shoot, yeah, I'm so... Oh, gosh, sometimes I try and go too fast. Sorry about that. For whatever reason, I thought negative times a negative was a negative. But once you're here, you get your sign chart pretty quickly, and that gives you your increasing, decreasing, and whatnot. And of course, I drew everything backwards again, so gosh, I'm so bad at this. Sorry, apologies. And once I'm done that, I can say my increasing might be saying -infinity to -1, union 9/5 to infinity. Maybe I'm decreasing -1 to 9/5. I can see I've got a max here, the peak of a mountain, and I've got a min here, the bottom of a valley at 9/5. And that gives me a pretty good idea what my function's doing. What do we think?
I think it makes sense. I have a question. Is there another trick here with the graphing calculator to kind of get these, maybe do this a little faster?
The trick that you could do is, of course, graph the function.
Okay.
Because once you find your critical values, if I pair this information and I draw a graph, like if I go to the Desmos calculator and I see it's doing something like, let's make sure I do this right. It's gonna look something like this. Blah, blah, blah. Yeah, probably something like this. And what you could say is, okay, if I just orient, I know where -1 is. That's probably -1. That's probably 9/5. So I do need to solve this no matter what. But once I can see what that is, put a picture with it, I can see I've got to be going up here, down here, up here. And that's another way you can do it.
Okay, cool. Yeah, that's good to know.
And you can do the same thing with concavity, because you'll probably find there's an inflection point or where the second derivative is 0 somewhere in here, and you can see that's got to be the guy. In fact, do you guys want to do concavity, same function?
Sure.
Right on. Maybe I'll just copy and paste this guy. Or I'll scooch over. Blah, blah, blah. Come on, paste. Make it bigger. Yeah, let's say concavity, etc. So we'll say f of x, just as before, 5x cubed minus 6x squared minus 27x. I don't know why I'm rewriting it, but here we are. Last time we found the derivative was 15x squared minus 12x minus 27. But if I want to talk about concavity, I got to make it one step further. We'll say f double prime of x is 30x minus 12. And again, I can say set that equal to 0 and solve. I could also factor a smidge if I want. Doesn't really matter so much. Actually, yank out 6. And however way you choose to get it, you get that x is 2/5. And just as before, I could draw that number line. Maybe I'll put a little f double prime so I know that this is what I'm testing. If I want to use the factored form and use that positive negative trick, I can. Here, if I only have like really 2 factors, it doesn't make such a big deal, but we can choose some numbers, maybe 0, maybe 1. If I plug in 0, it looks like I get negative 12. So negative. If I plug in 1, 5 minus 2 is 3. 3 times 6 is 18. 18 is positive. And I can probably deduce the concavity as down like a frown and up like a cup. And so if I had to write this in interval notation, I would say concave down, negative infinity to 2/5, concave up, 2/5 to positive infinity. And since there isn't the derivative, second derivative is 0 at 2/5, and concavity does change, there has to be an inflection point there. Those both things have to happen. Maybe I'll say at x equals 2/5. And of course, the point would be 2/5 f of 2/5 if you wanted to compute it. But Christian, like you said, we do have a graphing calculator. We can use that as well. Because once I have this value, x equals 2/5, I could use the number line, or I could switch over to that Desmos calculator. It'll give me something that looks like this, just as before. And I can probably pinpoint, 2/5 is maybe about here, if I just kind of guesstimate. And if I just follow the general curvature, I can see, yeah, this is frowny, this is smiley, and that's how I could get the intervals for concavity if I wanted to do it that way.
Okay, and then which function is it that you're plugging in the graph? Is it the one at the top, the double derivative one?
Yeah, so the graph, if I was going to graph this, I would want to use the graph of f of x.
Mhm.
And if I wanted to use the number line, that's when I'm using f double prime.
Okay.
So yeah, you're absolutely right. You got to be careful. What's the right guy that you're looking at? So most of the time, if you actually use a graph, it's going to be the original function. Because that's what we're sort of trying to acquire data on. The derivative and the second derivative are really telling us the same derivative, or excuse me, the same information, but in a different way, if that makes sense.
Okay. And I have a quick question. I noticed in the homeworks we don't use union. It's mostly comma.
Oh, yeah.
I just want to make sure it stays like that for the test, right?
Mhm. Yeah, sorry. Yeah, sorry, we got set theory on the brain.
No worries, just making sure.
Yep. Yeah, nope, comma separated list. Yep. Yeah. So we touched on some increasing, decreasing, mins, max, concavity, inflection points. Is there anything else that we missed on here that you guys want to see?
Um, I mean, I know we're running short on time, so I just want to get in one more question. Is there
Yeah,
any
of course.
other any videos we can watch like to prepare ourselves since we don't have a recording of this besides like what's on the homeworks? Anything like compiled into one?
Yeah, because I mean, I was about to say like, oh yeah, go to the modules in Canvas and look at those videos. Yeah, because I've heard people have opinions on those videos. A lot of people don't care for them.
Yeah,
Um,
I'll take what I can get because it's worse when you don't have anything. So
yeah, I mean, honestly, what I would say, and like this is super important for any online course, I mean, math especially, you got to find what works for you and what you like. And the benefit is, or the good thing is, there are so many resources. If you say, like, I am not good at related rates, I need help. If you go to YouTube and you punch in related rates, and I know that's such like a cop out to say, just Google it or YouTube it,
oh, it's true, it's true. It helped me pass last semester, so
yeah,
just
I mean, there are just so many resources. I mean, and the thing about calculus, I mean, since its invention 300 years ago, it really has not changed. So different schools, different teachers using different books, different types of ways that they spread out the material. It's all the same material. So if you go to YouTube and you say, I want to do this related rates, I need help, somebody is doing it. And they might have a different way to go about it that you think like that's better. I like that compared to what I've learned. And as long as you find something that works for you, you're going to be golden.
sounds good. So you just break it down by concept and go from there.
Yeah, exactly. I mean, of course, like if you YouTube ASU Math 210 Exam 1 review, I mean, you're probably going to get the lecture videos because they're all on YouTube. But if you find a specific topic like concavity help, and punch that in, there are so many resources like Khan Academy, Purple Math, Paul's Online Math Notes. There's so many people doing the same topic, but potentially different ways.
Yeah, and sometimes it's just the way someone teaches. Like you'll find the same problem on YouTube, explained by three different people, and it's like that third person that
Yeah.
kind of gets through.
Or you'll say, like, I don't understand the way my teacher taught me. Let me find somebody else. And you might not like how that other person does it, but maybe it's like, oh, now I understand what my teacher was trying to say. Once I see like this shed in a scent, like looked at in a different light, I can
Mhm.
see like that's really what's happening. And that's all about math is there's so many different ways to explain the same topic and the way that you like, you might not realize it at first. I don't know. Sorry, not trying to get super meta about it, but
No, you're good. Sometimes I skip a problem and I learn how to do it in like a later problem. It's kind of funny.
yeah, exactly. That's the thing. Math is not it's not something that you can learn linearly, or I feel like it, and I'm sorry, I don't mean to take up too much of people's times, but I feel like to learn math like one topic after next, after the next, after the next, that doesn't do you any favors because real life is not, you don't learn things that way, but like so you need to kind of bop around a little bit. And especially like these homework problems, I hate like you have a homework over this topic, this topic, this topic. It really should be you do a related rates problem, a limit problem, a first derivative problem. And that's the only way how you really solidify is you do a lot of math and not in any concrete order.
Yeah, definitely. I can agree. And I think that's the difference between Alex and Edfinity. Edfinity, there's a lot of reinforcement on a specific topic before moving on. And
Yeah.
this like they're just throwing you different things. And I'm like, wait, slow down. Like, wait a minute.
Yeah. Yeah. But yeah, we gotta find how we learn best. Yeah. Any other questions? Anything, any topic anybody wants me to hit before closing off? Everybody knows how to get to the exam. Everybody did the honor lock practice quiz. Wasn't too painful.
I didn't get a chance to do the quiz. I was working on the homeworks and stuff. So um I did honor lock last semester for college algebra, so I'm pretty confident in the system. I just gotta download the extension and get the
Gotcha.
ID picture and all that stuff going. But other than that, I'm pretty confident.
Excellent. I will say anybody, if you didn't do the honor lock practice quiz, that's totally fine. But try doing, I know the exam's open for like 48 hours starting, God, tonight. Wow. Yeah, midnight. If you can, try to do it Sunday or as early as you can. Just because, God, my C-session course for the first exam, like people would start it at like 10 p.m., run into trouble, and then I can't do anything about it. So if you're running into any issues, email me immediately and I will do my best to get on and remedy the situation. I'm on call all weekend, so don't be afraid to email me.
Okay, I have a question about that quiz because I was under the impression when I saw your first message that it's just like to test out the system, but
That's
we're also testing out the system and practicing questions, correct?
yeah, I mean
Or no?
there were two dummy questions on the honor lock practice quiz.
Mhm.
That was like 1 + 1 = blank or 2 times 8 is something. The questions weren't worth any points, but it was just to see if you could get honor lock to work and to see like what the types of questions will look like or what the format is. And it's very similar to a homework assignment.
Okay, but I think I did that in my last class where we kind of just tested it out, but it's not doing like a full practice exam too, right?
No, 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 no. It's just two dummy questions, just two basic algebra computations.
Okay, okay. Yeah, I think I could do that.
Yeah, okay. Cool, 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 cool.
Yeah, I was just trying to prioritize the stuff that's actually graded versus the extra credit stuff.
Okay.
I didn't know it was gonna be just like I thought it was gonna be like a whole test.
Oh, no, no, that was just the real practice test is this stuff.
Okay, cool.
Yep.
Professor Weaver, this is Chris. So I actually contacted HonorLock about the extra credit quiz because
Okay.
it would not allow me to take the quiz. It kept bringing me to an Infinity page that wanted me to relog into Infinity, which I was already logged into in order to take the quiz.
I see.
And they told me today that that was not their problem.
Okay.
So I don't know
So
if anybody else ran into that, but I tried to take it a half a dozen times. And I'm actually very concerned that when I go to take the exam, the same thing's going to happen. It also would not allow me to access the calculator in any respect. That's why I asked the question.
gotcha. So were you able to get onto the quiz eventually?
No.
So how do you know you weren't able to access the calculator?
When I went into the Infinity, when I went to click on and I was sharing my HonorLock screen, like when you do the screen sharing thing, if I tried to click off to get onto the calculator, it would kick me out. And that might be because I wasn't fully in the first place. So it looked like I was opening up a secondary tab.
So when you tried to do the practice quiz, you were in Infinity.
Correct.
So so there's a very specific set of instructions that I sent out how to access anything through HonorLock, and the way to do that is to start in Canvas. If you go to Canvas,
Yeah.
there's a side tab, HonorLock ASUO. you have to do it there, and it'll take you to Canvas from there. If you start in Infinity, try to access anything through HonorLock, it's just not going to work out.
No, I used Canvas. Canvas brought me to Infinity, and then Infinity said I needed to log in, and I couldn't log in at all.
Gotcha. Yeah. Okay. In that case, I would honestly say either try to update your version of Chrome, maybe use a different device. That's why we have the practice quiz here. If you're running into issues and your device is not compatible, that is an indicator you might need to use something else.
Okay. I used the HonorLock my last 5 classes, and I didn't have any issue with my current system, but I will see if I have the most up-to-date Chrome extension. That's a
Yeah.
good point.
Yeah, updating Chrome. Yeah, and I know like people are like, I use HonorLock for all these other things. And I'm like, I know, but like it's so dumb. The extension updates and it doesn't. You might also try deleting the extension, re-downloading it. Yeah.
Oh, okay.
Yeah,
Yeah,
these are
I did the
like
same
a lot
thing.
of these things. And I wasn't like trying to hound you, like you have to start in Canvas, but like from like my experience with it, a lot of people have that trouble that they try and access it in Infinity first, run into problems. But yeah, you know what you're doing, do it through Canvas. Just try to make sure everything's up to date. I know it's unreasonable to ask you to have a second device, but like if you have a friend's laptop on standby that you might try just in case, yeah. Because I know like HonorLock, some of the stuff like it doesn't work with Chromebooks, ironically. Yeah, I would just try to be flexible, keep things up to date, delete and re-download if you have to. Yeah. And that seems to solve like 90% of the problems that I've heard about.
I have a question.
Okay.
Yeah, and I would also like again, like if you can try to do the exam earlier in case you need to contact me or the folks at HonorLock because like they can get you in anywhere. But I mean they're like probably you'll have better luck during the day instead of yeah the people who do try to like email me at like 10 p.m. the night it's due is like are just out of luck. So give yourself plenty of time and yeah try to be flexible and I know it's a garbage system. That's why I'm glad I'm not recording the Zoom because yeah. Yeah. Sorry, Christian, did
Sure.
you say a question?
Yeah, I had a quick question about the extra credit, like honor lock quiz thing. It says I think on Canvas um like my grade dropped after not doing
Yeah,
the
that's
home.
that's another thing I need to send. I'm gonna because I gotta email you guys tonight. I'm gonna put this in there. That is a bug on Infinity. That yeah, a bunch of people who forgot to do the extra credit are saying, why did my grade go down? That's not how extra credit works. Um, it's because Infinity will not let you yeah, Infinity does not understand extra credit. That's the problem. And by default, since the practice honor lock quiz is categorized as a quiz, it gets weighted as it would a regular quiz. So that honor lock quiz is weighted just as much as the module one quiz. And obviously that's not okay. That's something I need to adjust. I will fix that.
No, I'm guessing you have to fix it in Canvas, like separately.
Oh, well, that's the problem because anything I do in Canvas, because Infinity will sync to Canvas, anything I do in Canvas will get overwritten by Infinity. Um,
Oh, that's tough. That makes your job harder.
yeah, it does. If you guys hate Infinity, just know I hate it more. That's something I need to meet with the course chair about it to try and rebalance it. I don't think I can. I think things are set in stone. But at the end of the semester, no matter what, I have to export everything into an Excel sheet and reweight things anyway. It
Okay.
will get fixed. I promise it is on my radar.
Okay, that makes me feel better.
Yeah.
And anything we can do to make your lives better by like doing it, even though it's already past due, like will that fix it or no?
No, that doesn't do much. But I will address it. Like I said, I'm gonna email you guys tonight. Just saying, reminder the exam opens. So you get like a daily email from me.
Sounds good.
Yeah. Um, Yeah, it's so dumb. But I'm aware of it. Anything else you guys want to talk about? Will Canvas calculate our grade correctly? Yes, once I fix that bug. Because at the end of the semester, Allison, when everything is done with Infinity, I will stop the sync. So they'll be like disconnected, they won't talk to each other, and then I can reweight things. So it might take a while, be a few days after the final exam. Yeah, the final grade calculation anyway. We got to go in and readjust a few things, but we're on it. Looking at the chat, what else? Some honor lock stuff. Logged on to different Google accounts. Oh, I didn't think about that one. Yeah, be careful because I got a few Google accounts and I run into issues with my extensions sometimes. Also, if you guys have an ad blocker, because like I know I do, you might have to, excuse me, pause that in case there's any pop-ups. Because I think there's a pop-up in the honor lock when you get into the exam, just with some of the rules, but try disabling your any other extensions. That's been another issue is extensions interfering with each other. Will there be another extra credit opportunity? Allison, at this point, I don't see one on the future, but there might be after exam 2. I'm not sure yet though. Okay, I think that's everything in the chat I see. Yeah, anything else, folks?
I have one more question. In the email that you're gonna send, will you send us like instructions of like what to do if we have technical issues the day of the exam? Like what?
Yeah, let me jot that down. I gotta go into Infinity, do a bunch of stuff.
Yeah, I'm an early bird, so I'm planning on doing it Monday morning, but that way I have time if there's any problem.
Yeah, I can do that. I'll just send some last minute info and some useful tips.
Yeah, anything you could throw our way, screenshots always help, like when it comes to like the step-by-step instructions. That way we're already stressed out about the test. Like we don't need tech problems, you know?
Right. Yeah, I think I got something. I'll send you guys something here in a few hours.
Thank you so much, Professor. I really appreciate this session. It really helps a lot.
Yeah, no problem. Happy to be here. Um, yeah, if you guys have any other questions, you got my email. Just send it my way. Cool. Well, if there aren't any questions, maybe we'll end it here. I got to do a couple things in Infinity before the exam opens. But I will email you guys tonight with a reminder that when the exam opens and some technical tips and tricks if you run into troubles. It'll be great. It'll be fun. It'll be an exam. It's gonna happen, whether you like it or not, but it'll be great. Alrighty, well, take care. And if you guys have any questions, send me a message. I will see you all at the next one. Take care.
Thank you.
Yep. I'll close out